I think we should get started on this. We'll do question number 1, then we'll do question number 2, and we'll do question number 3. Number 1 is just a standard linear equation. It's a little bit harder because it has fractions in it. So what I'm going to do is I'm going to take this 3 and put it over 1 so that I see that everything looks like a fraction. And if you recall, one of the ways that we do these equations with fractions is we multiply everything by the common denominator. Now we look at the denominator and it's 4, 2, and 1. And the number that goes into all 3 of those numbers, they all divide evenly into that is 4. So our common denominator is the number 4. I'm going to take, spacing this so I have the space. I'm going to take the 4 over 1, that's my common denominator, and I'm going to multiply everything by that common denominator. Now that means I have to distribute this to each one of the terms. So I'm going to be doing 4 over 1 times the x plus 2 over 4 minus the 4 over 1 times the x minus 3 over 2 equals the 4 over 1 times 3 over 1. And what happens then is over here, the 4 on top cancels with the 4 on bottom. And this leaves me 1 and 1 here. And we do 1 times x plus 2, and that just gives me x plus 2. Over here, the 2 cancels into the 4. It gives me a 2 here. This, of course, is 1. So that means I have to multiply this x minus 3 by what's in front of it, which is negative 2. So it becomes negative 2 times x, which is negative 2x, and negative 2 times negative 3, which is plus 6. Be very careful about watching the signs. And finally, here nothing cancels out, so it just becomes 4 times 3, which is 12. And I'm going to continue it over on the board over here. Line over here. Okay. So now we have just a regular equation. That's the point of multiplying by a common denominator. It gets rid of your fractions and you have just a regular equation. So we're going to combine the like terms and we're going to get x minus 2x, which is going to give me negative x. And then we have a plus 2 and a plus 6, which is a plus 8. And that's going to give us 12. So now I'll bring this 8 to the other side, which will give us negative x equals positive 4, 12 minus 8. But I don't want to know what negative x is. I want to know what x is. So I'm going to divide what's really in front of that. The x is a negative 1. I'm going to divide both sides by negative 1, which will give me x equals negative 4. And the people who sent me in those answers, I gave you credit for both of them. That is correct. Negative 4 was the correct answer. See, this is see if this will work better. Okay, so now let's look at question number 2. Number 2 is not an equation, it happens to be an inequality. And what we're going to do is we're going to solve this inequality and we're going to give our answers in 3 ways. As an inequality, which is the way it comes out, as an answer on the number line, and also in what we call interval notation, because we could be asked to do any one of those methods. Okay, so the first thing, but we work it just like a regular equation. So the first thing we're going to do is remove the parentheses. So we're gonna get -5 times 5x, which is gonna give us -25. Oh, this is, sorry. Switch, I keep switching. Okay. That's him. -25x. Then we have -5 times 14, which gives me -70. And that's less than the -30x minus 40. And we look on each side separately, and there is nothing that we can combine on each side. So we're going to bring all the x's. Remember, when we're doing an inequality, we want to bring all the x's to the left side and all the other numbers to the right side. So I'm going to add 30x to both sides. So that'll take care of the x's on the right side, which will leave me -25x was 30x, which is 5x, minus 70, less than -40. Remember, you have to keep the direction of the inequality. And then I'll add 70 to both sides. And I'm going to again go up there. So that when we get on the left side just the 5x, because the 70 cancels out. And on the right side, we have -40 plus 70, which is 30. Once we get to the place where we have all the x's on the left side and all the numbers on the right side, we are then going to divide by the coefficient of the x. So in this case, we're going to divide by 5. Don't forget that this is where crucial. Everything until here is just like a regular equation. But when you get to this last step, if the number that you're dividing by is a negative number, you're going to have to change the direction of the inequality. But we're dividing by a positive number, so this just becomes x less than 6. We don't change the direction of the inequality because we're dividing by a positive number. Only when you're dividing by a negative number. So this is how your answer would look as an inequality. On the number line, it would look like this. Here's the 0, 1, 2, 3, 4, 5, 6. Over here is a 6. Since this is just a plain less than, you're going to make an open circle. And this looks like it's pointing to the left, so our arrow has to go to the left. That is what it would look like on a number line. And in interval notation, we're starting, remember, in your interval notation, you always start on the left and go to the right. On the left side, well, it's going all the way out. So on the left side, it's going to be -infinity. And on the right side, it's going to be 6. And at infinity, we always put a parentheses, whether it's positive infinity or negative infinity. On the other side, depends on whether this is a filled-in circle or not. This is an open circle, so that is also a parenthesis. If this would have been a less than or equal, we would have filled in the circle and we would have made a bracket. So here's the answer as an inequality. Here's the answer on the number line. And here's the answer in interval notation. Okay, so now let's look at this last question. This last question is an absolute value equation. Now, that means that the first thing we have to do when we're solving an absolute value equation is to get the expression with the absolute value all by itself. It's called isolating the absolute value. So there's a 6 on the outside. I'm gonna bring it to the other side, so I'm gonna do plus 6 to both sides. So that'll give us the absolute value of x plus 6 is equal to 12 plus 6, which is 18. And before you go any further, you pause right now and you say, is the number on the other side of the absolute value a positive number? There are two places where you have to have a positive number before you can proceed with the equation. One is with the absolute value, and one is with a radical. When we get to radicals, I'll remind you of that. But this is, if it's a negative number, if this would have been a negative 18, I would have stopped right there. It's an impossible problem to solve. You can only solve absolute value equations if they're equal to a positive number. If they are, which in this case it is, then what you're going to do is you're going to break this up into two equations. One equation is going to be the x plus 6 equaling to the positive 18. And the other equation you're going to get is x plus 6 equal to negative 18. You must get two equations. If you just wrote one equation, then you only got half the answer. And in a multiple choice question, half the answer is just basically wrong. So one answer is going to be x equals 18 minus 6, which is 12. And the other answer, again, minus 6, it's basically the same thing, is negative 18 minus 6, which is negative 24. So your answer is 12 and negative 24. Both of those answers have to be given in this problem. So that's a basic review of what we learned in chapter 1. Does anybody have any questions before we go on? Okay, so now I'm going to go back to what we had talked about on Wednesday. There weren't a lot of people here, but whatever I taught, I taught. So here we go. Starting with a fresh board. We talked about something called the Pythagorean theorem. The chapter or the topic we're talking about now is something called right triangle trigonometry. Which is basically the study of a right triangle, which is a triangle that has a 90-degree angle in it. And as in every triangle, it has three sides and it also has three angles. One of the angles has to be a right angle and a 90-degree angle. It's the type of triangle where you get a square corner. A right angle makes a L shape. And we talked about giving a name to this triangle. If we use the letters A, B, and C, usually we use capital letters at the angles. And when we're doing that, we always use the C as the angle that's the right angle. We also talked about how we could call the sides by two letters, like I could call this side on the bottom AC, but it's easier to use just one letter, but you can't use just one letter that's a capital because we've said the capitals belong to the angles. So for the sides, we use lowercase letters. So when you see a lowercase letter, you know it's going to indicate a side. When you see a capital letter, you know it's going to indicate an angle. And it's done very specifically. If I look at this side here, this one over here on the bottom, directly across from it is the angle B. It's across from angle B, so we call this side small b. This side is across from angle A, directly across. You see, it's not attached to angle A, it's right across from it. We call this lowercase a. And this one that's across from the right angle, and the right angle we're calling C, is going to be called small c. Now, the small c and the capital C, maybe I should make my capital C a little bit bigger, are hard to distinguish. The A and the B, it's very obvious that they're lowercase letters. We give a specific name to the side that's across from the right angle. It's called the hypotenuse of the right triangle. The other two sides, the ones that are not the hypotenuse, there are two others, are called the legs. So this is a leg, one leg, and this is one leg. So in every right triangle, we're going to have two legs and one's hypotenuse in the right triangle. And the Pythagorean theorem, which is what we talked about on Wednesday, is a formula that was discovered by a Greek mathematician called Pythagoras, so therefore the name is called the Pythagorean theorem. It goes like this. In any right triangle, a squared plus b squared will equal c squared. Remember, I'm using lowercase letters, so that indicates the sides. By the way, in the angles, we also know something about, because in any triangle, all the angles will add up to 180 degrees. Sure, you've heard this before. So if one of them is 90, the other two, which we call acute angles, they're less than 90, together add up to 90, so that all three of them add up to 180. But the sides have a special formula, a squared plus b squared equals c squared. So if I have any question that looks like this, where it says, find the if A equals 5 and B equals 12, and I'm going to give this as a multiple choice. Here are your choices. A is 169, B is 17, C is 13, and D, these are your choices, is 11. And I'm going to give you a minute to work this out. If you have an answer, you can put it on the chat. Choice A, choice B, choice C, or choice D. Okay, I think we should maybe do this together. We'll do this one together and then I'll give you another one to try. Anytime you're told about a right triangle and you're given two of the sides of the right triangle, and here usually, as I said, we call this A, we call this B, we call this C. This is a small a. I usually do it in the standard way, but you don't have to do it this way, but it's just easier if we always do it the standard way. We're told that for our problem, that A is 5 and B is 12, and we want to find what C is. And C is the hypotenuse. So I have to do A squared plus B squared equals C squared. So I'll do 5 squared plus 12 squared equals C squared. 5 squared is 5 times 5, which is 25. 12 squared is 12 times 12, or 144. That's what your C squared is equal to. So you do 25 plus 144, that gives you 169. But 169 is not your final answer, because 169 is not what C is, it's C squared. So therefore, in order to find out what C is, we have to do the square root of 169. Now, you could try all the answers and see which works. But ideally, what you're going to do is you're going to take out your calculator, and hopefully you have a calculator, right? You do have a calculator. And you take the square root. I hope you know how to do that. You take the square root of 169. And of course, that gives you 13, which is choice C. And I see somebody sent me a text. Let's see what they picked as the answer. Kiana, that's absolutely correct. You picked number C, and that was the correct answer. Gave you some extra there. Okay. Here's another problem of that sort, maybe a little bit more complicated, but basically the same idea. I'm going to erase all this because we don't need that. But make sure you know how to use your calculator. If you have any problems or you don't know certain things, how to do the square root on a calculator, etc., then you can always be in touch with Patrice. She's always here, and she can help you, or you can make an appointment to meet with me. I'm always here before class, usually by 10 to 8, I'm logged on. You could always ask me then. Makes sense if you're going to do that, you let me know ahead of time that you're coming on so that I can make sure to be here on time. Okay, this is a question that's off a final exam. It says find the length of the third side of the right triangle. Where appropriate, give it both an exact answer and an approximation to 3 decimals. So here's what the question looks like. They give us a picture of a right triangle. They're calling this side B. They're saying this side is 5 times radical 3. And this side is 9. And they want us to find what side B is equal to. And here's the example, the choices they're giving us. Choice A is the square root of 6, which is they give as in decimal form as 2.449. Remember, 6 is not a perfect square. So the square root of 6 is irrational, and it's a number that we can take from our calculator. Obviously, an irrational number goes on and on forever. It's a non-ending, non-repeating decimal, but if it said correct to 3 decimal places. The next question they give, the answer they give is the square root of 41, which is 1.118. Choice 3 is the square root of 156, which they give equal to 1.565. And the last answer they give as a choice is the square root of 66, which is, they say, is equal to 1.251. So I want you to pick which is the correct answer for choice for this, for B. Give you a few minutes. You definitely have to use a calculator for this. Everybody should be sending in a answer. Okay, I'm going to take attendance while you're doing this. Okay. I'm looking at the okay, Isis, I see you're here. Carly, I see you're here. Kiana. Caleb, of course I know you're here. Kiana, Kiana, I see you're here. Ariana. Shania, so you're here. Glad to see you're back, Shania.
Yeah, I'm here.
Yeah, how you feeling? We missed you.
I'm okay.
Good. And Tahira, I see you're here. And I see Kiana has picked choice D. Let's see if that's the correct choice. Yeah, and I'm giving you credit for it anyhow, whether it's correct or not. Okay. So this one is a little bit of a tricky one for a couple of reasons. Number one, there's a square root in the question. We have to know how to deal with that. Number two, if you look at it, if I'm going to do a squared plus b squared equals c squared, we have to know what is the a, what the b, and the c is. We use this Pythagorean theorem when we have two right triangle, which we have, and we know two of the sides, and we want to find a third side. Now, obviously, they're calling this small b, which means this must be the capital B because they have to be across from each other. This is the right angle, which means this is what we always call the C. So this would be my small c, which leaves this to be the capital A because it has to be ABC, which means that this is the small a. Very important to keep in mind that the side opposite the right angle is the hypotenuse. That's what we call the C. So if I put this in the form into the equation, I'm going to get the A, which is 5 times the square root of 3 squared plus B squared equals C squared, which is 9 squared. Okay. So now we have to do what is 5 times radical 3 squared. Now there are two ways of doing it. You could put it into your calculator by doing parentheses, but just like I did over there, parentheses, then 5, then your square root button, and then your 3, close it, and either press the square button or just multiply it again by itself. And it turns out to be equal to, I didn't close the parentheses, so you have to be really careful. It gives me 75. Five times the square root of 3, but let's do it with on paper. Means to do 5 times the square root of 3 times 5 times the square root of 3. So how do we do that? It'll show you that it comes out to be 75. Remember, when you're multiplying radicals, you multiply the numbers outside, 5 times 5, that'll give you 25. And then you multiply the radicals together. Now you could do radical 3 times radical 3 and say it's radical 9. But if you remember, whenever you're multiplying a radical by itself, you just get the number that's inside the radical without the square root. So this actually becomes 25 times 3, which is 75. So this becomes 75 plus b squared. Now we have to do 9 times 9, which most people should know is 81. Again, you could do it on your calculator. And you subtract the 75 from both sides, because this time I was given the square root. So this gives me b squared equals 81 minus 75, which is, remember, I'm not adding them, I'm subtracting them, gives me 6. And that means that b has to be the square root of 6. That's why choice C is wrong and choice A is correct. It's the only one that makes sense. If you check it on your calculator, doing your square root button, you do get 2.449. It goes on beyond that. Square root of 6 is 2.449489,743. It keeps going. But for the first 3 decimals, it's 2.449. So that is the correct answer. So this is what we call the Pythagorean theorem. Right, let's go on from the Pythagorean theorem. This is not really trigonometry. Trigonometry deals with the angles of the right triangle and the relationship of the angles to the sides. And there are going to be what we call 3 primary trigonometric numbers, values, and 3 secondary. I'm going to start with the 3 primary. These are you're going to see as buttons on your calculator. What are these? The first one is something called the sine, which in your calculator you'll see a little button that says SIN. Not written, it's red sign, it's not SID, red sign. The second button, you might see it usually right next to it or right below it, is called the cosine, which is labeled COS. That's the abbreviation for cosine. And the last of the primary trigonometric functions or values is something called the tangent. And you'll see it on the button, its abbreviation is TAN, tan. Okay, so the question is, what do these stand for? So we're going to look at a right triangle. Again, we're going to take our standard right triangle. I like to call this A, but it doesn't have to be. This is B. Remember, the right angle we always call C. And again, this is our small a, this is our small b, and this is our small c, as we've done before. Now, each one of these trigonometric numbers, I'm going to call them trigonometric functions, represents the ratio, the fraction you get by dividing 2 sides of the right triangle. And it always, I'm going to write it over here, is written, let's say I want to find the sine, we always have to look at it relative to the angle that we're talking about. We're always, so it's never going to be just sine alone. It's going to be sine A or sine B or sine C, whatever your angle is. I'm going to specifically talk about A. The sine of A is defined as the ratio of the opposite side to the hypotenuse. So what does that mean? I'm going to put some numbers in here so it'll make more sense. Let's say side 5, let's use some really easy number. Let's say side A is 3. Let's say side B is 4. If you work it out, if this is 3 and this is 4, this will work out to be 5. These numbers 3, 4, 5 are what are called the Pythagorean triple, because if you do A squared plus B squared, you'll do 9 plus 16 is 25, and the square root of 25 is 5. So this is a particular one of the right triangles that we could talk about. Now, if I look at angle A, relative to angle A, I can label the sides. Obviously, the 5 is the hypotenuse. Hypotenuse is always the side that's across from the right angle. But there'll be 2 legs. And one of the legs is across from angle A, and one of them is next to it. The one that is across is called the opposite side. The one that's attached to the letter, part of the letter, part of the angle, it's right next to it, is called the adjacent. The word adjacent means next to. So one of the legs is next to angle A, and one is across from it. Notice adjacent and opposite refer to legs. Now there you have to be careful. The hypotenuse is always the one that's across from the right angle. It's also next to angle A, but we're not talking about, when we say the word adjacent, we mean the adjacent leg. So if I want to find the sine of A, I'm going to go to angle A, and I'm going to do the opposite side, which we see is equal to 3, over the hypotenuse, which is equal to 5. Every one of these things, the sine, the cosine, and tangent, is a fraction. It's a ratio. Now, very often these ratios are changed to decimals, so sometimes you'll see it, if you do 3 divided by 5 on your calculator, you'll get 0.6. So either you could say that the sine of A is 3 over 5, if you wanted it as a fraction, or you could say it's 0.6 if you change the fraction to a decimal. Okay, what then is the cosine and what is the tangent? So the cosine, which we're going to write COS, again, we're going to talk in terms of A, is the adjacent side, the adjacent leg over the hypotenuse. Again, it is a fraction that you get by dividing one side of the right triangle by another. In this case, if we want the cosine of A, the adjacent side we know is 4, and the hypotenuse is 5. So in a fraction, it's the number for this particular triangle, the cosine of A is 4 over 5. If you wanted, you could also change that to a decimal. Again, the way you change to a decimal on your, you go to your calculator and you do 4 divided by 5. That's what a fraction line means. It means divide, and it comes out to 0.8. The third of these primary trigonometric functions is called the tangent. The tangent of A is defined as the opposite leg, just going to write opposite, over the adjacent leg. It's only one. Again, you notice how each one of these values is taking to the sides. So you could take the opposite with the hypotenuse, you could take the opposite with the adjacent, you could take the adjacent with the hypotenuse. So therefore you get these 3 different values. In this case, the tangent of A is going to be the opposite side, which is 3, divided by the adjacent side, which is 4. And if you change 3 divided over 4 to a decimal, 3 divided 4 will give you 0.75. Most of the time, these decimals, when you get them, they become very long decimals and we round off. But in this case, these decimals turned out to be very nice, easy numbers to work with. These are the primary trigonometric functions of the triangle. Now, let me see if I can give you a problem to do, and then I'll explain some more. What's going to be, first of all, let me give you a little hint. What's going to be the hardest part of this whole thing? It's remembering what is the sine, what is the cosine, what is the tangent. If you're just new and you never did this before, it's going to be really hard to remember because it could be any 2 sides. So there's something called a mnemonic device, a way of remembering something that makes it much easier. And that is called, you might have heard this before, so sounds like you're soaking your toes. So you can picture, if you want to remember it, you can picture somebody coming in from the cold, very cold, so they put their feet in a bucket of hot water, and so katoa. How is that going to help you? Because these are the first letters of each of them. So if sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So now we're going to write this right at the top of it, especially when you're going to take a quiz or something or test. The first thing you're going to write is this thing, SOHCAHTOA, right on the top of your paper. So that's going to help you remember what is the sine, what is the cosine, what is the tangent. Okay, I'm going to give you another problem to do. I'm going to do another one with you, and then I'll give you one to try. Okay, so let's say this one is the one I'm doing with you. I'm putting in, this is A, B, and C. Here's our right angle. And they tell me that this side is 3. And I'm putting in the lowercase letters, they figure you might know it. And this is the second side they're giving us. And they ask us to find the cosine of A. So here's how I go about doing something like that. As soon as I see the COS, I know that stands for cosine. I know I'm talking about trigonometry. I know it's SOHCAHTOA. The C is the cosine. So we do CA, which means the cosine is the adjacent over the hypotenuse, right? So I'm going to label my sides of my triangle opposite, adjacent, hypotenuse. So we want the cosine of angle A, so I'm doing it from the perspective of angle A. Angle A, the opposite side, is this one. This would be our small a. This side is the hypotenuse. And those are the ones I usually label first, the opposite and the hypotenuse, which leaves the third side, what we call the adjacent side. Which makes sense because it's next to the A. Remember, it's asked for cosine A. This question asks for cosine A. We're going to then talk about what happens if they would have asked for a different one. So I know to find the cosine of A, I have to do the adjacent side. Oh, I know what it is. It's 7 over the hypotenuse. And the problem is I don't know what the hypotenuse is. But I already know two sides of the right triangle. I know one side is 3 and one side is 7. This is, let's just call this is our small a. This is our small c. This is our small b. We know A and B. We know the opposite and the adjacent. We don't know the hypotenuse. But that's where the Pythagorean theorem comes in. Whenever you know two sides of a right triangle, you can figure out the third side because you use the a squared plus b squared equals c squared. So even though the Pythagorean theorem is really not part of trigonometry, you really can't do a lot of trigonometric problems without knowing this. So we want to find out what C is. So I'm going to put in the A is 3, the B is 7, and the C is what we're trying to figure out. So this becomes 3 squared is 9, 7 squared is 49. That gives me C squared, which means that C squared is 9 plus 49, which is 58, which means that the C has to be the square root of 58. Because I don't want what C squared is, I know what C is. The hypotenuse is the square root of 58. So now I can put in what the hypotenuse is. My cosine of A is 7 over the square root of 58. And that would be the correct answer, but they said they want a rational denominator. A rational denominator means not a square root in the denominator, but we know how to take care of that. Remember, in order to rationalize the denominator, if it's just one number, you multiply this by the square root of 58, because we know that the square root of 58 times the square root of 58 is going to give you this just plain 58. And the numerator you multiply by the same thing because you don't want to change the value. So this comes out to be 7 radical 58 over 58. And this doesn't reduce anywhere, so this would be your answer. 7 radical 58. Before I give you another problem, I want to show you 2 things that you have to be careful about. Number 1, let's say I gave you this triangle. Again, this is my A, this is my B, and this is my C. Doing another problem. And let's say I say that this side is 13, this side is 12, and I want you to find the tangent of B. I didn't ask for the tangent of A, I asked for the tangent of B. Now, again, I'm going to do what I did before. What do we see? So, ka, toa. Tangent is opposite over adjacent. So I have to go to side angle B, which is all the way up here, and label the sides opposite, adjacent, hypotenuse. I always do that first. Before I go into trigonometry, I want to know what is my opposite side, what is my adjacent side, what is my hypotenuse. Well, I really usually label the hypotenuse first, because the hypotenuse is always easy to tell. It's the one that's the longest side. It's the one that's right across from the angle, the right angle. This is your hypotenuse. It doesn't matter whether you're doing tangent B or tangent A, the hypotenuse always stays the hypotenuse. But now I was asked for tangent B, so I have to look at everything from the perspective of angle B. So if I look at it, the opposite side to B is this. In other words, I don't always put the adjacent down here. It depends if I'm looking for the tangent of A, or the sine of A, or whatever, or the tangent of B. That's why it's important to label this. In this case, since we're looking for tangent B, the one that's across from B is called the opposite. And of course, this one then becomes the adjacent. And again, I'm going to call this is my small a, this is my small b, and this is my small c. And to find the tangent of A, I have to do the opposite over the adjacent. So opposite is 12, just like we had before. But adjacent, I don't know. They didn't give me the adjacent side. They only gave me the hypotenuse. So I again have to use my Pythagorean theorem on this triangle. So I'm going to do a squared, which I don't know, plus b squared plus 12 squared equals c squared. That's 13 squared. So that'll give me a squared plus 12 times 12 is 144. Again, you could do this on your calculator. It's really important that you have a calculator because these numbers become pretty big. And 13 squared is 13 times 13 is 169. And when I subtract 144 from both sides, because I want to find out what a squared is, that's going to give me a squared equals 169 minus 44, which is 25, which means that the a is the square root of 25, which is 5. This adjacent side is 5. So therefore, this becomes 12 over 5. And if they ask you for it in fractional form, there it is. You don't have to rationalize this denominator because the denominator is already rational. If you want it in decimal form, you would take the 12 divided by 5 and you get 2.4. but usually the answer is given in fraction form. Again, if it's got a radical in the denominator, you have to rationalize the denominator. Okay, I'm going to give you another question, which is from a final exam, so you can, can I erase this? Everybody okay with my erasing this? Okay.
Yes, if you resume.
Okay. So I'm gonna put another problem on the board. And I'm gonna give it to you as a multiple choice question. Okay. So here's the picture. Okay. I want you to find sine theta, and I have to explain what this is. And here are the choices that they're giving you. This is a multiple choice question. Okay. Notice they've rationalized their denominators. There's no radical in the denominator. And the question is find, and there's this little symbol, and I may as well explain to you what it is. It looks like a 0 with a line cutting across it. It happens to be a Greek letter. It's called the Greek letter theta, because this whole study of trigonometry and the Pythagorean theorem really started out with the Greeks. A lot of times Greek letters are used. And specifically when they use, so this is just a hint. Whenever you see a Greek letter being used, and the most common one, it's like when you use X for a variable, in the most common Greek letter that's used is this theta symbol. If we come across any other examples with different Greek letters, I'll mention it. But I'd say most of the time it'll be this theta. And it's used as the name of an angle. In other words, the Greek letters are used like the capitals. So if you see, instead of they're calling this angle B, they're giving it the name theta. So that's all that they want. They want us to basically find the sine of angle B. So sometimes they'll use a Greek letter inside. Usually when they use that Greek letter, they won't put it on the outside. The outside, they put the capital, regular capital letters, American alphabet, or English alphabet, really. Or if they use a Greek letter, they'll stick it inside the angle. Usually they don't give you both. Sometimes they give you one, sometimes they give you the other. Okay, so basically I'm asking you to find the sine of B. So we want to find sine theta, which I'm going to write over here, is really the sine of B. Okay, I'm just going to remind you what you have to do. You have to remember what the sine is, and you have to label the sides opposite, adjacent, and hypotenuse. And if you have the sides that you need, fine. If not, you may have to find the third side of the triangle. Okay, I'm giving you a few minutes to try this. We must just mention trigonometry is a very, very helpful and useful mathematical study. We're just touching the tip of the iceberg. We're just explaining what the different names stand for and figuring them out specifically for numbers. We're really not going into how this could be useful. We saw how the Pythagorean theorem could be useful because it helps us find another side of the right triangle if we know two sides. Turns out, I mean, it's beyond the scope of this course, that trigonometry, sines, cosines, tangents, can also help you figure out different sides or different angles of the triangle. Again, we're not doing that in this course. That's, I hope most of you are going on to pre-cal. In pre-calc, you'll learn all about that. Okay, Kiana, let's see if you're correct. I think we should, I'm going to give you your extra credit in any case. Kiana, you're doing a good job today. Okay, let's work on this together. Okay, so first of all, I'm going to label As soon as I see they say sine or cosine or tangent, I'm gonna label my sides. Opposite, adjacent, hypotenuse. Now they want the sine of theta, which is over here. So this is my opposite side, which is my B. This is my hypotenuse, which is my C. And the third side is the adjacent side. This is our A. How did I know that? Because I always go first to the opposite and then to the hypotenuse. And the third side has to be the adjacent. Remember, this is opposite because we're talking about sine theta, sine B. Okay, the sine we know is SO. SO stands for opposite over hypotenuse. So we have to take the opposite side, which I know, and put it over the hypotenuse, which I don't know. You see how similar all these questions are. But again, I know these two sides of the triangle. I know the A and the B. The hypotenuse is a C. I can do A squared plus B squared equals C squared. The important thing is to label your triangle correctly with opposite, adjacent, hypotenuse, and the ABCs if you're using them. So this is going to be 5 squared plus 3 squared equals C squared. So 5 squared is 25 plus 3 squared, that's 9, is my C squared. And 25 plus 9 is 34. So my C is the square root of 34. So going back to this, the opposite over the hypotenuse is 3 over the square root of 34. And we know we're not supposed to leave a radical in the denominator. We have to rationalize the denominator. And if you notice, none of those choices are over there. So we multiply by the square root of 34 over the square root of 34. So on top we get 3 radicals 34. And when we multiply square root of 34 times square root of 34, that just gives us 34, which is indeed choice A. Perfect. Perfect. That was really good. Let's do one more question of this type. And then we'll finish this topic on Wednesday. Okay, here's another question. Suppose I tell you that I know that the tangent of an angle theta, I'm going to call it theta, is 5 over 9. And I want you to find the cosine of theta. Now, as soon as they notice they didn't give you any right triangle. But as soon as they talk about sine or cosine or tangent, you know you're talking about a right triangle. So let's draw ourselves a right triangle. My standard right triangle, A, B, C, small a, small b, small c. And they're not using A, B, and C, they're using this Greek letter theta. So I'm going to stick the theta in here. If they don't tell me if they don't give me a picture of where to put it, I find it easiest to deal with the angle over here at the bottom. Now, according to theta, this then is going to be our opposite side. This is going to, of course, be our hypotenuse, and this is going to be our adjacent side. If you notice, the hypotenuse is always where it always is. It never moves around. But the adjacent and the hypotenuse depend on which angle you're looking at. At what perspective? Are you using it from this perspective? Then this is opposite. If you're looking at it from this perspective, then this is opposite. But we're looking at it from this perspective, so this is our opposite, this is our adjacent. But I wasn't given any sides of this right triangle. The only thing I was told was that the tangent of theta is 5/9. Now remember what tangent stands for. Tangent is TOA, opposite over adjacent. So if I put it as 5/9, it must be that the opposite side is the 5, and the adjacent side is the 9. In other words, by telling you that the tangent of theta is 5/9, I'm telling you in this triangle, the opposite side, which was over here, we can call 5, and the adjacent side over here, we can call 9. So we know two sides of the right triangle. That's the point of telling us, instead of giving us the sides on the triangle, they gave it by telling us what the tangent is, which is essentially telling us two sides. Now, they want me to figure out what the cosine is. Now, what is a cosine? The cosine is ca. It's adjacent over hypotenuse. So let's see, do I have, in this triangle, do I have the adjacent side? I certainly do. I know it's 9. But I don't have the hypotenuse. And therefore, I have to do what I did before. I have to do a squared plus b squared equals c squared. In other words, they don't have to give you the exact sides that you want, because if you have two sides, you can always use the Pythagorean theorem to find the third side. So in this case, we're going to do 5 squared plus 9 squared equals c squared. So 5 squared is 25, and 9 squared is 81. And if I add these together, I get 106. So that's what c squared is equal to. So c has to be the square root of 106. So it turns out that the cosine, the adjacent over the hypotenuse, is 9 over square root of 106. And again, we don't like to leave that square root in the bottom, so we're going to multiply by the square root of 106 over the square root of 106, which will give us 9 times the square root of 106 over 106. I don't think it reduces it all. So this would be your answer in rationalized form. Okay. Start reviewing for your final exam. I'm going to be posting shortly a practice final exam, certainly sometime during this week, and I will send out an email when I do that. I will give you, I'm going to give you several chances to work on it. It won't be limited just to one. I may even give unlimited chances. And I will use your best mark on that. Make sure you take it, because I'll use your best mark on that as a class quiz mark. So not only will it prepare you for the final, it'll always give And if you're gonna have several chances to do it, if you don't do well the first time, you can redo it and until you know how to do it. If you have any questions, you can certainly bring them up in class. So we're going to be continuing with our study of trigonometry, but we're going to be reviewing chapter 2 in the book. That'll be the beginning of the class. We'll start off with reviewing chapter 2, which is graphing of linear equations and how to write the equations of lines. So that's where we're going to be next time. Okay, unless there's some questions, I'm going to end the meeting now. Any questions? Okay, so have a good day. I will see you Wednesday. Make sure the last few days, the last couple weeks are extremely important.
I have a question.
Sure.
Wait, not for you, for Patrice, but she's not here.
What?
When is her tutor?
Oh, you mean Patrice?
Yeah.
She was here at the beginning of the period. I don't see her now. Look, I'm pretty sure on Blackboard I've given you her email address. The best thing is to email her and find out what her exact hours are.
Okay, I'm gonna email her.
What?
I'm going to email her. Thank you.
Okay. Okay, she is you can talk to her in person in school. Okay. Any other questions? Okay. Have a good day then.